Okay, in this video, we're looking through worked examples to do with the equation of a least squares regression line, especially in the context of not calculating it through your calculator, but using the equation that you've already seen. So it's to generate this equation here, where we work out what b is using sy and sx and r, and where we then, knowing b, having worked out what b is, we put b in there, and then this is to work out a, we're going to go the mean of the x and y, and as up here, you've got your standard deviations, your Pearson's correlation coefficient, and your standard deviation of your y and your x. So we'll be using that in the two worked examples that I'm going to go through. Okay, so keep that in, and I'll keep having to refer back to this, and that's fine. And it's worthwhile having something like this in your summary book to have it, so it's a reminder. You can go, oh, hang on, that's it. That's what I need to use. Okay, so let's start on this. So the heights x and y of 11 people have been recorded, and the values of the following statistics determined. So we've said x is basically the heights. So this is the heights stuff. This has to do with the heights. Okay, and this is to do with the weights. Okay, and if you had noticed like me, that probably should be kilogram. That should be kilogram. Okay, and we've been given an R value there. Now, use the formula to determine the equation of the least squares regression line that will enable weight to be predicted from a height. So I want to be able to use the equation and say weight equals whatever the equation will give me. Okay, so remember, first off, what we're after is y equals a plus bx. So that's the equation that enables this prediction. Okay, so as you can see, remember here, b is the first thing we need to work out. So we're going to go b equals r times sy over that's x over sx, as you can see here, remember. So that's where I'd go 0.8502 times 7.5943 divided by 7.4443. And remember, that goes there, and this one was to use there. Okay, I'm going to get rid of those arrows now just because they're going to get in the way, but just want to remind you where those came from. That equals 0.8673. So I've already found what b equals, so let's highlight that. B is going to go here. Okay, now we're going to go a equals y bar minus b x bar. Y bar is 65.45 minus 0, hang on, I don't know what's going to write. That was, yep, so it's 0.8673 times x bar is 7. No, wrong thing, I'm looking at the S, sorry. X bar is 173.27, oops, 2727. Did it again. That equals 84 minus 84.82. Okay, so we've now worked out what A equals. Okay, now we can go, well, let's go y equals initially. Y equals what's A? A is minus 84.82 plus, and then we put our b value in, 0.86, I hate when I forget letters and numbers in there, 8673 times x. I'm just putting a time, let's actually get rid of the times there, just to and that's x. That's not the final answer though. Final answer is we say the weight, so it's in terms of the variable, equals minus 84.82 plus 0.8673 times, and x, our x was the height. Okay. Okay, so that would be your answer. That's your final answer here. Okay, that's what you'd need to do. Now, let's look at this second worked example. So, study finds a relationship between the height of husbands and the height of their wives, revealed the following details. This is one of those questions, ones where, to a degree, the height of the wife, the height of the husband, unless you're told which one's the explanatory, which one's the response, I wouldn't have a clue on this one. So this is one where you'd have to be told. And you are, but you'd have to be told. Okay, so if we want to look at that in that context then, height of the wife, y, so that means mean height of the wives, y bar. Standard deviation height of the wives, sy. Okay. Height of the husband, that's going to be x. Okay. That means mean height of husbands is x bar, and that's sx. All right. We've got a correlation coefficient of 0.85, so r equals 0.85. And I've sort of answered A, which is the response variable. The response variable is the height of the wife. Okay. Height of wife. Okay. So B is calculate the value, B, you always say B is calculate the value of B correct to two significant figures. Okay, so that's where we need to do. So B over here will be, remember, B equals R times, if we go up here, SY over SX. SY over SX, okay, that's equal to 0.85 times 4.8, and because that was what we've got there, 4.8 and 5.3, and that will give you a value of 0.7698. Now, if you're in SAC or an exam, very good chance you're going to lose marks if you left it like that, because it says two significant figures. This is representative of two significant figures, so 0.77. Okay, so that's B. So we've got this value here. All right, so that's our B value. So calculate the value of A correct to four significant figures. So question part C is, and remember, A is, if we have a look, A is the y bar minus b x bar. So y bar minus b x bar, and if you remember y bar here, well, y bar's up here, y bar's 169. 169 minus, we said our b was 0.85. 0.85 times our x bar, which was 180. Okay, and that will give you a value of 30.44. Okay, so, and that is in four significant figures. That was, what the answer would be there. All right. If we need to, I'll go through what significant figures are in a separate video or in class. Okay. Now, this is where we've got to do to express, what it's asking for here. We're sort of skipping one point, which we're going to talk about first, is how would we, to express the equation in terms of x and y, or to express it in terms of variables. In our case, we need to do it in terms of variables, okay? But let's first do it in x and y. So we're going to have y equals, well, a plus bx. A is equal to 30.4. 30.4. And then it's going to be plus bx. is going to plus 0.77 x. And what that means is, remember our y was, I'm just going to say wife rather than height of, because we know it's talking about height wife, equals 30.4. Actually, let's put height of wife plus 0.77 times height husband. Okay, so we do it like that. Now the question D is asking us to use this equation, and it's telling us the husband is 195. So they're saying that there is 195 centimeters. So what we do is we go 30.44. Let's go height of wife, 30.44 plus 0.77 times 195. Okay, and that value will be 180.59. But if you check what they're after, nearest centimeter, so the nearest centimeter to that is 181 centimeters. So that would be our final answer, and that's how you use these sorts of equations. Okay, thank you. Bye.